Hello, good afternoon. My name is Joshua Welsh, and I will be taking you through another Pure Math tutorial. So today we will be doing sigma notation. Now, sigma means summation. Another name for this topic is a summation notation. So it just means you add up. You're just adding up different that's the word for it. You're adding up different values of this function. So let me go through it with you. If a is less than b, and a and b are part of the set of all natural numbers, so it has to be greater than 1, greater than or equal to 1. Then we have a summation with a starting point of a stopping point of b, and a function of x, which goes on to which starts at a, so f of a, starting point, and finishes at b. So we increment by 1 each time till we reach b. So here's two examples of it. Summation, so a summation of x squared starting at 1 and stopping at 10. So we started 1, so we started 1, 2, 1 squared, 2 squared, 3 squared, incrementing by 1 until we reach the stopping point of 10. Then we have 1. Now here's another example of it, not an exception, but a different example, when it's not a function of x, but it's 1. So we have a summation of 1, starting point 1, but it stops at 5. So we just add, so it's just, so in this example, it will just be 5. So we'll just go 1, 1, 1, 1, 1 until we reach 5. And when I go on to the next slide, you'll see there's a rule for this. Very simple. These are some general ones that you should learn. I'm not sure if this still comes on your formula sheet or not, so you need to learn these. Instead of working it out, or like, instead of doing it like this, we have some general rules, here for them. So when there's a summation of 1, starting at 1 and ending at a value of n, then the answer will just be n. So like here, we started at 1, we stopped at 5, so we got 5. Here, same thing. We have a summation of x starting at 1 and ending at n. Then it will be n divided by 2 times n plus 1, and so on and so on. So you should learn these, and we're going to be proving these in the next episode through mathematical induction. Also, let me just stay on the slide quick, so in case you could pause the video if you need to write them down. So axioms for sigma notation. So these are some rules governing sigma notation. Pretty straightforward. There are only 3 of them. If there's oh yeah, I gave 3 examples for the 3 axioms. So just look at it. It should be straightforward. A function of a constant multiplied by a function of r. Usually in sigma notation we use r, by the way, as a starting point. So a summation of a function of r times a constant will just be a constant times the summation of the function of r, which comes in handy if we're summating 2 functions that are adding or subtracting each other. We simply summate. Summate, is that a word? We add up, we sum the first function, and then we add it to the sum of the second function. So instead of trying to sum the 2 of them together, we could sum each one and add the results. And this one, if a is less than b, which is less than c, and a, b, and c are part of the set of all natural numbers, then if I have a summation from a to c, then we can split it up to a to b, and then c, b plus 1 to c. So I'm going to the examples now. Sorry if I'm going very fast in this video. It's because this is not really a hard topic, and I want to get to proof by mathematical induction. And honestly, the textbook does this very well, so just read. This is something you just have to read and like practice a bit to understand this. Nothing much to it. So some examples. So each one is one of the axioms. So the first one is if you multiply a function of x, a function of, if you multiply a constant, sorry, I'm getting a bit flustered. If you multiply a constant times a function of r, you can split it, so that's the constant times the summation of the function of r. So here, we have 3. We know from the axioms, we know from the rules that if we have a summation n r is equal to 1, and we have it as 1, then it's just n. But we have 3. So what we do is we take 3, pull it out, because it's a constant, and multiply 3 times the summation of 1, which gives me 10. And 10 times 3 is 30. So that's one example. Another one, the second one, we have the summation starting at 1, ending at 10 of 2r minus 1. So for this, we know, did I make a mistake there? Or did I write it down wrong? It's not, because I see a 2 there, but it shouldn't be a 2. Oh, it's a 3. So, yeah, it's a 3. So let me just get it quick, get the blue marker quick, so it's fixed. Actually, let me just scratch this off and go 3r, instead of doing all the extra work. Yeah, so this is what we have. So 3r minus 1, what we do is we break it up into its 2 parts, because we can't work this summation on its own. We would have to go the first iteration, the second iteration, the third iteration. So what we do, we break it up into 2 functions with 2 summations. The summation of 3r, which we then use this for. So we break up 3r into the summation of r times 3, this, and then we just summate 1, which we know the answer to is 10. So we have 10. So we have 10 from this summation, and then we have the rule that we gave on the side here. Yeah. The summation of x, or r in this case, is that. So we just plug it into this function. And then we get 155. So we work it out and we get 155. And then for this one, the last one said that if I have a summation from, let's say, if I have a summation from C to A, we could break it up instead of doing the whole thing. So I have a summation from 10. So I'm starting at 5 and I'm ending at 10. This is hard to do on its own. So what we do is we say, okay, let's take it from 1 to 10 and minus 1 to 4. That will give me 5 to 10. You understand? So we take this, so we break it up, we subtract, and we have the answer. So sorry if I did this a bit fast. It's nothing much to teach really. You just have to see it and like do an example on your own. But yeah, that's it for this episode. Stay tuned till the next one.